Guten Morgen, my name is Gaurav. Today in this video I'm trying to demonstrate an experiment where I will be performing simple programming to program a microcontroller. In this video I will try to show that how the embedded world works, how the programming of embedded devices work, the microcontrollers. So in this video I'm using this ESP32S3 microcontroller to program. And before starting I would tell, as you can see in my screen, I'm using this window, but for programming point of view I use or I prefer Linux environment because it's in professional way of dealing or completing any project. So for this thing I'm using a WSL, Windows Subsystem for Linux, where I will be performing these tasks, and I will try to go step by step so that anyone who is watching this video can learn the things and everything will be easier for them also. So without wasting our time, let's get started. So first of all I will start this terminal. Okay, so here first I have a inbuilt directory ESP. I will activate, and that in this I will create the project idf.py, create project. Let's think any name, anything, we can take the name of this project. So now we can make it like Orion. Okay, now Orion is created as a project. So now cd csp Orion. Okay, now because we are in the directory, so we need to go inside the main file so that only we can program this. So again we will type this Orion / main. Now I will show you the CMake file, CMake, nano CMake. Look, we can see that the environment has been set up correctly. So you can see this main file orion.c. Here it's showing include. So here if you are like expanding your project, have some particular or many application, in that case you can include that thing also in this, and then in that case your project will be like as per your requirement. So as of now we are just creating a simple hello world. In that case we are not supposed to change anything, so we will just put Control X and we are out of this. And now we have to write the code. So nano, name of the project is orion.c. Look, because we have already downloaded the software, so everything has been created by the software itself. So only we just need to program this. So let's get started with the programming. I will try to explain some of the parts which are essential for the programming. First we will write the basic things like include driver / gpio.h, then okay, now because we need to define our GPIO pin. GPIO can be defined as general purpose input output, and These pins are used to do the experiment, like we can send the input to the microcontroller, gets the output from the microcontroller. As of now, in this case we have the inbuilt LED, so we will just program that inbuilt LED to be blinked here. So we will just write, or we will define this, define LED underscore pin, then GPIO underscore num underscore tool. Usually, because this is inbuilt LED here, so in that case most of the ESP32 have this inbuilt number 2 GPIO is connected with this inbuilt library. That's why I'm using this. And then we have to go to the main function of our code. So first I will set here everything. So GPIO underscore set underscore rectio in direction. In that case, LED underscore pin GPIO underscore mode, because we need to explain everything to the computer, because computer understand the computer, not the human language. In that case, in order to understand, or in order to make the computer to understand that what we are asking to the computer, we need to define accordingly. So here now, because our task is to blink an LED, not to just flash a LED, we need to blink it time to time. It needs to be turned on, turn off. So in that case, we need to create a loop. So that loop will make this code, or make this form in that way, so that it can be blinked timingly or accordingly. So in that case, I will create a while loop. While loop will be helping us to blink the LED, in that case a small curly bracket, and then in that case I will say GPIO underscore set underscore direction, or set label here, not direction in this case, and then LED underscore pin, and then 1. This level should be high in that case, so that our LED will be turned on. Here it's not necessary to write this printf, but we will write this printf LED, so that it will look some professional when we will execute the thing. So let's see. And because we need some delay, in that case there is a inbuilt thing we can write in. So we task delay, and how much delay we need, 25 seconds or something maybe, because we need to watch this blinking as soon as possible. We will just put 500. That's it. 500 will be quite enough in that case, and then we will close. And now we need to turn off the LED also. So in that case, GPU underscore set underscore level, and then LED underscore pin, because if you study this electronics, in that case the state is high means 1, if the state is low, in that case we need to put 0. So here the 0 will be there. Okay, and then printf, and then we will say LED off. Anything, you can write anything here, even if you can write your name, it will look cool, but as of now we will not write that. And then we will say we task delay, and the delay should be of 500, we will say. So we will see this continuous blinking, and then we will close our bracket, while loop bracket. Here it's closed. In order to look it more, make it this code more professional, in that case you can leave some comments also. So like here, like in while loop we will go, and here we can write turn the LED on, can write, sorry, here you can write turn off the LED, and here also you can write something. What I can say, wait, I will say here, I will comment delay. Here also I can write delay, so it will look some professional way of doing or handling the same delay. Now you will see anything. Do we have any mistake in the code? I don't think there would be any mistake. So we can see studio driver GPIO FreeRTOS, and then thus we have defined this LED pins as GPIO number 2, and then yeah, so yeah, I think we can go ahead. So far so good, everything. So we will put Control X, Control Y, exit. Now it's time to perform the experiment. We need to first go here out of the main file. So cd esp/orion, the name of our project. As of now, if I will go and compile the project, it will run, but the issue will be that, like in that case, we can't see any result. The reason is that I will show you. We still have not connected our ESP32, so I will use and I will connect it here. I think you can see it to the USB port. It's connected, but we are using the WSL, Windows Subsystem for Linux. In that case, there are some issues. So in order to resolve that issue, in order to connect the USB directly to the WSL environment, you need to open the PowerShell, run as administrator. I will show you. You need to type USB IPD list. Look, you can see now USB IPD. I need to bind my device with the Windows Subsystem for Linux. In that case, bus ID. It's showing 1-1, so I will write 1-1 and then enter. It's showing the device is already been shared. That's very good. Then now we will attach. The main thing is you need to attach this. So USB I attach. I will tell we need to attach in the WSL. Then bus ID is bus ID 1-1. Okay. Now it's already been connected. So now we can easily perform our experiment. Still there are some issues. First, we need to tell to the software that we are using ESP32 S3. So we will write here idf.py set target. Set target will be like set target, and then ESP32 S3. Enter. Yeah, now it's done. Now our next task is we need to set up some of the menu configuration. So idf.py menu config. It will open the framework configuration where we have to change some of the things. So first we will go to component configuration, and in this we need to find where is ESP system settings. So I can see, I think it is here. We need to put enter, change the clock, it's 240 megahertz, escape. Then we will go to serial flash configuration. Because this ESP32S3 have the flash memory size of 4 MB, we will go to 4 MB, escape, and we need to save this configuration which we made here. So shift Y, it's done. Now it's time to build the project. So idf.py, idf.py build. Let's see, maybe everything will work. Nice. It's taking some time, but it will be done. If there won't be any issue in the code, it will run. If there will be some issue in the syntax and something, in that case might be the issue, but no, there are no any issue. So it's showing that your project has been successfully done. We can check it. So now it's time to see our experiment at what we did. So it's already been connected, it's showing. Just follow this, see the screen also, and see the commands which I'm going to show here. So I will put idf.py and I will type flash, F-L-A-S-H. If I will put enter, you can see there will be some changes. The form will get loaded inside this ESP32. So let's see. You can see here. Yeah, now in this the form has been all successfully loaded. Now we have to monitor whether the things are working properly or not. So I will say idf.py and then we will say monitor. Okay, enter. Look, and it's showing LED on. We need to wait something for some time. Look, LED off, and see something. There should be something. We'll go look. The blinking is going on for some delay. Which look. Just now see the screen and see this microcontroller, and you can just match it simultaneously. It's showing LED. When LED is getting on, it's here you can see the blinking, as well as you can monitor that, and you can, when it's getting off, you can see on the monitor showing LED off. So this is the basic programming which I did. I was trying to just demonstrate that how the embedded system, how the embedded environment work. In upcoming video I will make big projects. I will also try to make something like related to AI. I will try to implement some AI in the embedded system, and in that case it will behave like its own, like if you ask something, or it can be able to predict and all lot of things like that. And I will also show a lot of experiments, so stay tuned and maybe hope we will get some better results. Look, it's working. So this is the way that you can perform the experiments. So this is all about the video. Thanks for watching. If you like this video, thank you so much, and hope I will create another video and maybe you can like that one also. So stay tuned. See you.